Hi, and welcome back to this series. We started implementing our GraphQL API. We added the event type. Now it's time to also add a database behind the scenes so that our data is not just persisted in memory, as I'm currently doing it, which is of course not a great solution for a real application, but that we instead persist our data in a real database. Now in this video, I'll use MongoDB and we'll set it all up from scratch and manipulate our code such that we really use that database. Of course, you could use any database though. Now, let's implement it step by step. As I mentioned, I will be using MongoDB here to, as a database for this project. And you could use a MySQL database, you could use PostgreSQL, you could use other NoSQL databases. So GraphQL really doesn't care. It works with any database because we will write the logic to interact with the database. That's not built into GraphQL, as you will learn. Now, I'll use MongoDB because I really like it. It's really fast, has good performance, really flexible. And if you want to learn more about MongoDB specifically, I got a whole video and a complete course on MongoDB, and you'll find links to both in the video description. And these are awesome resources to learn everything about MongoDB. Now, here I will specifically use the cloud-hosted database solution MongoDB offers, MongoDB Atlas, because I don't want to take care about administrating and setting up that database. Now, for that, you will need an account. You can click on Get MongoDB, and on that page there, you can choose Cloud, or that is actually selected by default. And here you can sign up. And you need no credit card for this. You can start with this for free. So you can sign up here and you will thereafter be prompted with a screen where you can set up your first MongoDB Atlas cluster. And there you can choose all the free tier options and you will end up with a cluster. Here I already am logged in. That should look something like this. So this is the screen you see after you configured and started your cluster with all the free tier options. So where you don't pay anything. And as I said, you won't even need a credit card therefore. Now, once you have that cluster up and running, we of course want to connect our application to it. And to do that, we need to do two things. The first thing we need to do is manage our security settings here on the cluster such that our application is able to connect to the database, because not everybody should be able to connect, of course. The second thing, which is important, is that we also use a tool, a driver, in our application, so in our GraphQL API, which is able to query the database. Because we won't write queries ourselves in a special language like SQL has it, instead we will use a tool that exposes methods we can execute against the database. And I will walk you through all these steps now in this video. Let's start with the security settings here on the security tab. And there you should make sure that you have at least one user who's either an admin, who's basically able to do everything, or has read and write any database rights, which means this user can read and write to any database you have on your cluster. Because on this cluster you can have multiple databases. We will only use one, but you can use a user with these rights. Now, on such a user, you want to set your own password or auto-generate one. And I will quickly show it so that I can copy it, because we'll need that later. And I will click Update User to use that new auto-generated password. And the other thing we need to do is that we not only know the user credentials, but we also have to decide which servers can connect to that database cluster server here. And there, under IP whitelist, I got a bunch of IP addresses here because I used this cluster for other projects too. You probably have none of these addresses there. What I want to do there is, I want to add an IP address. Now, I already added mine, so I will quickly delete it here. And thereafter, I can click on Add IP Address, and now choose Add Current IP Address. And this uses your local IP address, so of your local machine where we will do the development. If you later deploy this API onto another server in the web, you will need to use that IP address or that IP address range of that web server, of course. Here I will confirm to add my local IP address, and now I'm both allowed to connect from my local host to that MongoDB server, and I will have a user who has all the right access rights. With that, we can switch back to the application, and now in here, we need that other part, that MongoDB driver, that package that allows us to interact with MongoDB. Now here we could use the native MongoDB driver, a package managed and maintained by the developers behind MongoDB, but I will actually use Mongoose. Mongoose is a third-party library you can install through npm, which in the end builds up on that official MongoDB driver and adds extra convenience features, and most importantly, it allows us to work with models. So it allows us to manage our data through JavaScript objects. And for example, when we then save such an object or execute certain methods on it, then this automatically is translated to a query against the database, which persists the data there too, or fetches it from there. And therefore, I will install this through npm with npm install -- save, and then it's Mongoose like this. Now that installed this Mongoose package, and with that we can now restart our server here with npm start, but I will actually not do that. Instead, here I will add a nodemon.json file, and this will automatically be used by that nodemon tool we use to start our server, and there we can add some configuration for that nodemon tool. And I want to pass in an environment variable, which basically holds my sign-in credentials for the database, because I can then easily swap them by just editing them in that file if I later were to deploy that. Or to be precise, we wouldn't even deploy that file. So we can basically set up our credentials for our local development environment and later easily use other credentials when we deploy the app. And for that, in here, I need to add an nth key. And in that nth object, I can now set up environment variables, which will automatically be injected into the Node.js application when it starts through nodemon, which we can then consume inside of the Node application. And there I will add a Mongo user. And here my username was Maximilian. Of course, you probably have a different username. And I have Mongo password, and that is that password I generated and copied. With that edited, this will automatically be consumed. And now in app.js, we want to connect to Mongoose. For that, I'll first of all, to MongoDB through Mongoose. For that, I will first of all import Mongoose here. And now we can use Mongoose to establish such a connection. And I'll do that towards the end of this file here. There I will use Mongoose, and this has a connect method. Now, this connect method, first of all, needs a connection string, which basically is the address of our database cluster or server. And we can get that string if we go back to that cluster, to the overview, and click on connect there. And this will open a modal. There we can choose connect your application, and then choose that which requires MongoDB 3.6 or higher, this SRV string. Copy that string and add this here. And now we'll actually use backticks here to create a template literal, because this will allow me to now dynamically change my username and my password here. So for the username, I will use, and now we can access this environment variable as we always do it in Node.js with process.nth dot. And then here I have Mongo user. So this first environment variable we added a second ago. And I'll also replace the password here, of course, with process.nth Mongo password. Okay, and now we construct this connection string. The connect method then actually gives us a promise, and here we could fail, so I will just log any errors we get. For example, we could fail if our cluster is down, if the credentials are incorrect, if our local network connection kind of is broken, or we succeed. And in this case, in the then block, in this case that we succeeded, I want to start up my server. Now, you could also have a setup where you always start your server, no matter if you connected successfully or not, and you then have some logic to retry the connection. I will take this route here. And now with that, let's run npm start to bring up that NodeMon server and try connecting to MongoDB. And this succeeded. We can ignore that the deprecation warning here. We got no error. So now I'm successfully connected to MongoDB, to my cluster, to my database. And now it's time to actually start adding some logic to interact with that database. Because thus far in my resolver here, in this file, create event, for example, I only store this in my events array here, and that is just in memory. Now I want to use MongoDB, and I want to use that strongly typed modeling feature Mongoose gives me. Therefore, I'll add a new folder here, which I'll name models. And in there, I will add an event.js file. And this will be a model, a JavaScript model created with that Mongoose package, because that package is all about using models to manage data so that we can easily implement a model view controller, or in our case, a model controller endpoint approach. For this, I will also import Mongoose in here in this file with the same syntax we used in app.js. And then I need a specific feature from that Mongoose package, which is called schema. And I will add a capital S here because whatever I'm going to access now will actually be a constructor function. And I get that from Mongoose, there is this schema property. And again, this points at a constructor function, which I can use to generate new schema objects. Schemas are the first important building block added by Mongoose, because we can now create an event schema here, and you can name this however you want, of course, by instantiating this with the new keyword. Since it is a constructor function, we can create a new object with it with the new keyword. And then we pass a JavaScript object here to the constructor function where we define the structure. And this allows us to define the structure of an event object, which we can then reuse throughout our entire app, and where we then are guaranteed that every event object will look exactly like this. Now, how should an event look like? Well, if we have a look at our app.js file, then we see that an event here in our GraphQL API has an ID, and this will actually be added automatically by MongoDB and Mongoose, so we don't need to add that. Then we will have a title, a description, a price, and a date. And later I will also add more once we added users and we want to connect an event to a user and so on. But for now, we can go with these 4 fields. Now back in our event model, in that schema here, we simply add a title property here in that object we pass to the schema constructor. And now I could add string here to define that this will actually be a string. And Mongoose, or MongoDB then, will respect this and will store the data as such and will yell at us if we try to use different data. But I will actually pass an object here because I can then configure this in greater detail. And there we have a type property, which I set to string to make clear, yes, the type of the title property will be string. But I will also add the required property to make clear it's not just a string, it also is required. So it must not be null. And that, of course, also fits our GraphQL schema, which is otherwise not related to the MongoDB schema, by the way. There I also have a non-nullable type because I added that exclamation mark. And of course, we kind of want to keep our MongoDB schema, which affects what we save in the database, and our GraphQL schema, which affects what we work with and what we return. We want to keep these two in sync, right? Because if we say in GraphQL, this will never be null, and we do allow null values in the data we store in the database, then we have a mismatch, which will ultimately lead to problems. So here I have my title. I will now also add my description here, and on this description, I will also set the type to string because the description will be a text. And this will also be required. There must not be an event without a description in my app. Of course, you could tweak this to your likings. I will also add a price here. And that will now actually be a number. There is no float in JavaScript. There is just a number. Integers and floats are both combined in that number type. And this will also be required. Now here I will also have a date then, and the type here will be date. Unlike GraphQL, where we had to use string, we do have the date type in MongoDB, so we can use it here. And of course, it will be our duty to convert this when we pass it back to GraphQL, to the frontend and to the database. And this will also be required. Okay, so this is my schema for now. Now, the schema alone doesn't help us. We now need to create a so-called model based on the schema. The schema kind of is like our plan, you could say. The model then is the blueprint which incorporates that plan, which we can then use to create objects with which we actually work in our application. We create such a model also with Mongoose by calling the model method, and this takes now at least 2 arguments. The first argument is that the name of the model, and here I want to name this event, and this has to be a string. This will affect the collection in which this gets stored in our MongoDB database, and it will also affect other things by which we can access this and so on. Now, the second argument here is a pointer at the schema we want to use for that model. And here I wanted to use my event schema, of course. Now, this creates a model, but in this file, it's not that useful to us. We want to use it in other files, and therefore I will export it with the Node.js export syntax, which is module exports equals this model. And now we can import that file into other files and consume our model there. Now, with that model setup, we made a huge step forward. Now, in app.js, I want to change one other thing. Here, I also need to define in which database this gets stored, because we connect to a cluster here and actually also to a database in a cluster. This is this part here after that slash. And if that database doesn't exist yet, it will be created on the fly. The same is, by the way, true with MongoDB for all collections and so on. It's all created on the fly if it doesn't exist. Now, I don't want to use test as a database name. Instead, I'll go back to my nodemon file, and in there, I will add my MongoDB field, and I will name this events React dev. You can use any name you want. This will be the name of the database, which will be created automatically. And now in app.js, I can replace this with some dynamically injected value, which is process.nth.mongodb, the name of that environment variable I just added. Now, if I save this, it will restart and connect to that database. And now any data we save will get saved in that database. So that is a lot of work already. Now let's finally tweak our code such that we actually do save our events in the database and that we do fetch the events from there as well. For that, in app.js, let's import our own model. I'll name this event with a capital E because the Mongoose model created by that model method here actually will also be a constructor function we can use to build JavaScript objects based on our model we defined here. I do import it by simply importing from that models folder and there that event file we created. And now we can use that event constructor here to create a new event object that we want to save to the database. So previously, we created this like this with the object literal way here. Now I will create my event by calling new event using that event constructor generated by Mongoose model. And there we now pass a JavaScript object where we pass fields or values for all the fields we defined in our schema. So in this case, in case you forgot it, you can quickly check. We got a title, description, price, and date field. So basically what I set before already. So here we can set the title, and this now should be a string. And basically I can copy that, right? Because that is exactly what I wanted to pass or store before. It still is what I want to store. One exception is the date here. The date now can be a real date when we save it in the database. I still will get it as a string, but then I expect this to be a string that can be parsed into a date object. So I can use the built-in date constructor and parse that incoming string into a JavaScript date object, which is then passed on and which will be stored in the database. And of course, MongoDB then also stores this in a slightly different format, but this is all basically transformable between JavaScript and MongoDB and the other way around. I then don't want to push my event onto some event array or events array. I will actually get rid of that array here. We don't need it anymore. Instead here, on this event object, since it is based on a Mongoose model, it's not a normal plain vanilla JavaScript object, I can call a couple of methods on that. And one method is the save method. This is provided by the Mongoose package, and save will actually hit the database and write our data as we define it here into the database. So here I'm saving this, and then I can call then and catch thereafter, because this actually returns not a real promise, but a promise-like object that for our purposes works like a promise. And then I either got an error, which I can catch, where I can console log the error, or where I have some result of that operation, and I can console log that result here too. Now keep in mind, we also need to return an event object here due to our GraphQL configuration, which basically tells us when we call create event, we return an event. And I can already tell you that result will basically be an event object, so I can return result here. Though to be very precise, this is like an enriched document or an enriched object with a lot of metadata. We can return a new JavaScript object here and use the spread operator to get result._doc, which is a property provided by Mongoose, which gives us all the core properties that make up our document, our object, our event object, and leave out all the metadata. And then we return this. Now, if we have an error, I of course also want to return something. And there I basically want to just throw that error again so that GraphQL, Express GraphQL, can handle that and can return us an error. This is our create event resolver here. Now, one important thing is you should return this here so that GraphQL, Express GraphQL, actually knows that this resolver executes an async operation at the end, and it will wait for this to complete. Otherwise, it would complete instantly and would therefore not get a valid result. So we need to return our promise here. Then we can use the rest of the code, get rid of our old event definition here, or object creation to be precise. With that, we should be good to go to really store an event in the database. Now let's give this a try on our localhost /GraphQL URL, where we can run our GraphQL queries and play around with them. And there we want to execute a mutation against create event, where we need to pass an event input. And there we have a title, a test, we have a description, this is a test. We got a price, which should be a float, so let's use $9.99 for example. And last but not least, we got the date. And here I will open up my developer tools real quick, because here I still need to pass a string, and I can generate one with the help of the developer tools here by just calling new date to ISO string. This will give me today as a string. I will copy that, close the developer tools, and pass that string here. And then we should get back an event. So of course here I will actually then, for example, fetch the title. Let me prettify that and execute this query. And this doesn't look too bad. I get back a title. Now let's look into our MongoDB database. And you should be able to do that here from inside that MongoDB cluster view by clicking on collections. If you don't have that button there, you can search for MongoDB Compass, which is a tool provided by the MongoDB company that also allows you to connect to your database and then inspect your database. So you can download that, it's free to use, and there you can visualize your data in the database and look into it. But here I got that integrated into my view here. And if I click on collections, it will load all my databases and all my collections. And I actually got more than one database. You probably only have the one we are working with. I got a couple of databases. I'm looking for my undefined database, as it looks like. So Seems like I made a mistake here. Process nth MongoDB. I probably should have restarted that. Now, that server here, because I changed Node.js with it running, didn't pick up the new configuration. Makes sense. Now, undefined is the database which was created here due to my mistake. We'll fix this in a second. But there we do have that events collection. And if we look into that, there you should actually find your event, which was created a second ago. This is the date I just generated. This is the price. So this all worked. Please note that the ID was auto-generated. It's that strange object ID type, which is a special data type provided by MongoDB. It's a unique string that is also taking into account the current timestamp. With that, we got that all working. Now I'll quickly just stop my server and restart. And I'll then execute that same query again. And now I will refresh here. And now I should have the correctly named database. There it is, events React dev. My mistake, I didn't restart after changing the nodemon config. But the most important thing is we are able to save the data. Now, saving data is, of course, one nice thing. We also want to be able to retrieve the data, right? So let's go to our other resolver where we return the events. And it's not that simple anymore. Instead of just returning some events array, which doesn't exist anymore because I deleted it, we can use the event constructor like this, so without new. And there we actually have a couple of static methods. So methods we can call on the event constructor function without actually creating an object based on it. And one method we can call here is find. Find allows us to, well, as the name suggests, find documents in that collection, so find event documents. We could pass a filter, so an object where we say find objects where the title is a test, for example. You can learn more about filtering in my MongoDB course. We'll probably also do it throughout the series. But if we don't pass anything here, it will give us all the entries in that collection, and that is exactly what I want. And then again, we have this promise-like API, where we can get an error, which I want to basically throw, or where we get the result, in my case, my events documents, and then I want to return these, of course, because our events endpoint here actually should return an array of events, right? Therefore, in here, we could now say return events, but just as before, the events data we get back by Mongoose actually has some metadata attached to it. So I will use the map operator here, and I will transform every event in that array that is retrieved by MongoDB into a new object. So I will return a new object for every element in events. And there I will use the spread operator and use everything from event doc like this. And with that, I leave out all the metadata. And then I can here also return this whole operation so that GraphQL, Express GraphQL, again knows we're doing something asynchronous here, wait for it to finish, and don't try to return something too early. Okay, now let's save that. Let's go back to graphical, and let's run a query now against events. And there, whoops, hit enter too early. There, let's, for example, fetch the title, and this works. And now let's also fetch the ID. And this will now actually give you an error. And that's good, because now we also see how an error looks like. We get this errors object, and there I get the error that the ID cannot represent this value. Now, the problem here is that special ID data type MongoDB uses, this object ID data type. This is something which is not natively translated into a string, or which isn't understood by GraphQL. So we need to translate it into a string. And how do we do that? Well, when we return our events here, I do pull out all the data in this doc property which Mongoose adds, which is all my core event data. And now I just can override underscore ID by adding it again thereafter, and this will replace the first underscore ID, which is pulled out of the document. And there I will call event doc underscore ID to string. to be very clear what I want to do here. So I will access this document with all its data. There I will access the ID, and I will call toString, which is a method which is available, which will convert this to a normal string that is then understood by GraphQL. If I save that, I can execute that exact same query which failed a second ago, and it now succeeds. And here is the string ID. Obviously, this is not just a problem when we get all events, but also when I return the generated event. There, I also want to override the ID with my result doc ID to string. Now, there is a shortcut, by the way, which is worth noting. Mongoose also gives us another property. We can access event ID like this. This is a virtual getter provided by Mongoose. And you see it now still works. This basically abstracts all this logic away. So we can use event ID, and MongoDB, or Mongoose to be precise, Mongoose will actually access the native ID and translate this into a string here. Please note that I also don't have an underscore here because this really is a different property. This is a property added by Mongoose to let us access the ID in an easy way. We could use it down there too. I will leave both methods here, or both approaches, so that you see what's happening behind the scenes. And now with that, we are able to query our events. Let's now also add another event again. Create event with our event input where we have the title, another event, the description. Whoops. This is another event where I then also have the price, let's say 129.99, and where I also have the date. And here, to keep it simple, I will just use that same date from before again. And then let's say I want to get that ID back and I want to get that title back. And if I hit enter, this works, proving the fact that we fixed that ID error for the mutation too. And if I try that query for all my events again, then you will see here I can, for example, fetch the titles and descriptions of all events, and I got more than one now. I got 2 events. Awesome. Now, this was quite a long video, but we did add MongoDB here. We now work with real data and we store it in a real database. In the next video, let's refine our API, let's restructure it a bit, let's work on that schema, and let's also make sure that throughout the next videos, we also are able to add users, book events, and so on.